Hello, and welcome to Kognito Key. Today, we're diving into a powerful, invisible force that's pretty much essential to our modern world. It's the driving force behind everything from giant industrial motors to the tiny bits and pieces inside your phone. Have you ever seen one of those massive electromagnets in a junkyard lifting a whole car and just wondered, how on earth does that work? What's the real force inside that big coil of wire making it all happen? Well, that is exactly what we are going to uncover today. So, to get right to the heart of it, here's our plan. We'll start with a basic idea, use a really helpful comparison, define the term properly, learn how to calculate it, and then wrap it all up with why it is so important. All right, let's get into it. Okay, first things first, let's set the stage. Just think about it. Water needs pressure to flow through a pipe, right? And electricity needs voltage to flow through a wire. Well, it turns out magnetic fields also need a push to even get started. And that something, that fundamental push, is kind of like a magnetic pressure. It's the force that drives or establishes a magnetic field, which in technical terms we call magnetic flux. Without this initial push, there's just no magnetic field. It's the cause that leads to the effect. Simple as that. Now, if this idea still feels a little bit abstract, don't worry, there is a fantastic way to understand it. Because what's really interesting is that we can compare it directly to something most of us already know pretty well, a simple electric circuit. Okay, this slide is the key to everything. Just look. In an electric circuit, you have voltage, also called electromotive force, or EMF, and it pushes the electric current. That current then faces some opposition, which we all know as resistance. Now look over at the magnetic side. The push is called Magnetomotive Force, or MMF. What does it push? The magnetic flow, which we call flux. And that flux also faces an opposition, called reluctance. Do you see that beautiful parallel? Voltage is to MMF what current is to flux. It's a perfect analogy. All right, let's move on and give this force a proper name and definition. Now that we understand the role it plays, thanks to our analogy, we can put some precise language around it. So here's the crucial point. Magnetomotive force, or MMF, is the official name for that magnetic pressure. It is the direct cause that sets up the magnetic flux, the magnetic field itself, inside a magnetic circuit. So no MMF means no magnetic flux. It's really that straightforward. And this shows us it's something we can actually measure. Sometimes you'll hear it called magnetic potential, which again really connects back to that idea of voltage potential in electricity. The standard unit we use is the Ampere-Turn, which is actually a huge clue as to how it's made, and we'll get to that in just a second. Okay, so we know what MMF is, but, in engineering and physics, we need to be able to calculate it. How strong is that push, really? Well, luckily for us, there are a few pretty simple ways to figure that out. This is the most direct and common formula you'll see. The strength of the MMF is simply the number of turns of wire in a coil, we call that N, multiplied by the electric current flowing through that wire, which we call I, and that's why the unit is Ampere-Turns. See? It makes sense. More turns or more current gives you a stronger magnetic push. Now this second formula, it takes us right back to our analogy. Just like Ohm's law in electricity is voltage equals current times resistance, the magnetic version is MMF equals magnetic flux times reluctance. The push equals the flow times the opposition. It's so consistent, it's actually beautiful. And finally, there's a third way. We can also calculate MMF if we happen to know the intensity of the magnetic field itself, that's H, and the length of the path that the magnetic field travels, that's L. This one is super useful for analyzing what's happening inside a magnetic material itself. So we've defined it, we've compared it, we've even calculated it. But why? Why have we spent all this time on magnetomotive force? Let's bring it all home and look at the big picture. These are the really crucial points to remember. MMF is the magnetic push. It's the twin sister to voltage. It's the cause of magnetic fields. And most importantly, by controlling the number of wire turns and the current, we get to control this force. This principle is the fundamental engine that drives so many devices we rely on every single day. It really gets you thinking, doesn't it? Understanding this core principle is the first step to creating new things. I mean, from hyper-efficient engines and medical imaging to completely new ways of storing data. Being able to control this force is absolutely key. It just leaves us with this fascinating thought about what the future could hold. Thank you so much for joining us for this explainer. If you found it helpful and it made a complex topic a little more simple, please do like and share it, and of course, subscribe to Kognito Key for more. We'll see you next time.